In this video, we are going to talk about functional groups. Specifically, we are going to discuss functional groups like haloalkane, alcohol, carboxylic acid, ester, aldehydes, amine, and amide. We will also be going through some practice examples and then see how do we name compounds that contains multiple functional groups or functional groups located at different positions of the carbon chain. So we know that we have alkanes and alkenes, and they can have other atoms attached to them. So we have briefly discussed this idea in the last video when we introduced the chlorine into one of our alkanes. So whenever we have some other atoms other than carbon or hydrogen attached to alkanes or alkenes, they are called functional groups. So why is this called functional group? So functional group gives characteristic properties to the molecule. So in essence, it alters the chemistry of that group of molecules. So this is why it's called functional group, because it serves some interesting functions. It changes the chemical property. So by chemistry, I mean chemical properties. So this is something like their reactivity. Whether they will react with certain species, the ability for them to be oxidized, but also physical properties such as boiling point and melting point. Because usually if you have different atoms, such as oxygen, which is very electronegative, you will actually create polar regions. And so this would cause an increase in melting point and boiling point. So that's why functional groups is important, and that's the reason why we are studying them, because they play a very important role in chemical reactions. So the first functional group I will introduce is called haloalkanes. So this is also briefly touched on in the previous video, but in this video we are going to make it more concrete. So by haloalkanes, we know that it is related to halogens, like chlorine, fluorine, bromine, iodine. And those halogens replaces one or more of the hydrogen. And the naming is as follows. So if you replace hydrogen with chlorine, then it is called chloro group. If you replace with fluorine, it is called fluoro group. If you replace with bromine, it's called bromo group. If you replace with iodine, it's called iodo group. Let's look at several examples. So for this chemical element, we see that one of the hydrogen atoms has been replaced with a chlorine atom. And because we know that the prefix, so this is called chloro group, is named as following. It's called chloroethane. Of course, we can also replace two of the hydrogens. something like this. And this will be named very similar as what we have discussed before when we have the different positions of double bonds. It's called 1,2 dichloroethane. So 1,2 indicates that the chlorine atom is at both carbon 1 and carbon 2. And di means we have 2 chlorine atoms present. And chloro means we have chlorine atoms rather than fluorine or bromine atoms that are replacing the hydrogen. And the ETH means we have 2 carbons in our main carbon chain. And the suffix ane means we only have carbon to carbon single bond. So that's how you decipher the name of organic chemicals. Of course, there are some other possibilities as well. And see if you can work out the name of this compound. So it also has 2 chlorines, and the carbon chain contains 2 carbon atoms. So we know that it should be something like dichloroethane. But in this case, the positioning is very important. We cannot just write dichloroethane, which would be incorrect, because we know that the chlorine atoms can be placed on either side of this molecule, or it can be placed on one side of the molecule. So the positioning, you may say, it could be 1,1 dichloroethane or 2,2 dichloroethane. But as we have discussed in the previous video, we want to make the number as small as possible. So we choose 1,1 dichloroethane. So let's look at a different example. So all the hydrogens have been replaced by fluorine, and we have a carbon to carbon double bond in this instance. So we know that it has 4 fluorine atoms. So the prefix should be tetra, means 4. And it have 2 carbons in the carbon chain and contains a double bond. So we know that it's replaced by fluorine. So it should be tetrafluoro based on the naming convention. And ethene. ETH represents 2 carbons in the carbon chain, and the ENE suffix means we have a carbon to carbon double bond. It is not necessary and incorrect to name this as ETH1ENE, because there's only one position that the carbon to carbon double bond can go, since we only have 2 carbon atoms, which is in between those atoms. So it is unnecessary to name the position of the carbon to carbon double bond. So based on our previous discussion, you may be tempted to write the name as 1122 tetrafluoroethane. But this is actually not needed, because it is already implied. If you have 4 fluorine atoms in this molecule, then you automatically know that all of the hydrogen atoms have been replaced by the fluorine atom. So without even knowing the position, by just knowing this name, you can draw out the entire molecule. Since there's only 4 places left to put fluorines, and you have 4 fluorines present, then all of the available places will be filled by fluorine. So let's have a look of this molecule. how do we name this? Well, you might be tempted to write this as 112 trichloroethene. But this is incorrect, because when you have 3 chlorine atoms, it can only be arranged in this way. So it is unnecessary to write 112. But if you only have 2 chlorine atoms, like the case before, then we need to specify the position, because there are multiple places or multiple possibilities that the chlorine atoms can arrange itself. But in the case of 3 or 4, there's only really one possibility. So we can go even more complicated than that. So let's have a look of this example. How do you name this? Well, let's start with the basic. You have 2 carbons in the main carbon chain, and you have a carbon-to-carbon double bond. So it has something to do with ethene. You have 2 chlorine atoms. So because you have chlorine atoms, it is chloro. Since you have 2, it is dichloro. And the position in this case becomes important, because we have only 2 chlorine atoms, and they have multiple possible ways to arrange themselves. So you need to specify their location. So one is on the first carbon atom, the other is on the second carbon atom. So 1,2-dichloroethane. But this is still incorrect. Remember that we have isomers when we have carbon-to-carbon double bond, because you cannot easily rotate the double bond. So we have everything on the same side. So we have 2 chlorine on the same side, 2 hydrogen on the same side. So you know this is cis arrangement. So the full name should be cis 1,2-dichloroethane. If you need some extra help with the cis and trans isomers, please refer to the previous video. Now let's look at an even more complicated example. So how do you name this molecule? The first question to ask is, where should we count the carbon chain? Should we go from left to right, or do we go from right to left? Because this will affect the relative position of the double bond and the chloro group. The convention is we prioritize the CC double bond. So we want to make the number in front of the CC double bond as small as possible, so it takes priority. Towards the end of the video, I will give you a systematic way to figure out which functional groups takes priority. But a general rule of thumb is that the haloalkanes or the chloro-fluoro-bromo group, they will not take priority. So whenever other functional groups are present, it always takes a low priority. So this is a useful rule for you to remember. And the next thing is to count how many carbon atoms we have. So we already know we should count from right to left to make the number in front of CC double bond small. So let's count. So first carbon atom, second, third, fourth, fifth, sixth. So we have 6 carbon atoms in our main carbon chain. And the next thing to do is, whenever you have a carbon-to-carbon double bond, you need to be very careful about its arrangement in space. So since we have, I think a very useful way is to just look at the hydrogen, just focus on the hydrogen, and because it is very short and easy for you to see. So we can see that the hydrogen is arranged on the opposite side of the carbon-to-carbon double bond. So it is a trans arrangement. And let's start to write down the name of this molecule. So we know that it has 6 carbon atoms, so it's something to do with hex. If you recall from the previous videos, hex corresponds to 6 carbon atoms. And because the carbon-to-carbon double chain starts on the second carbon, so it is hex 2 ENE. And we are not finished yet. We have 1 chlorine atom on carbon number 5. So chlorine atoms means we have a chloro group. And it's on the 5th carbon, so 5 chloro. And it is a trans arrangement. So trans 5 chloro hex 2 ENE. So this is the name of this molecule. So let's have a look of another slightly confusing example. So this is really about reading the question carefully. The actual naming should not be hard. So if you come across with things like this, I think if you are not really familiar with organic molecules, to rewrite or redraw this properly. Because whenever you see this, I think for me personally, it's very easy to misinterpret these two as the alkyl group. But if you draw this out in full, you can see it is actually the main carbon chain. So we have 3 carbons in the carbon chain, and we have both bromine and chlorine atoms present. So, and we don't have any carbon-to-carbon double bond. So it is propane, something to do with propane. And the problem is, do we write bromo first, or do we write chloro first? So this is another rule you need to know. You need to start with something that starts early in the alphabetical order. So B is before C, so B goes first and C goes second. So let's name this. So the bromine is on the second carbon atom, and we need to indicate this position, because if we don't really know where the bromine can go. Maybe it can go to here or here. You never know, so you need to indicate the position number. So 2 bromo. And similarly for the chlorine atom, because you have multiple possibility for it to be attached maybe to the 3rd carbon atom or the 1st carbon atom, you need to indicate its position. 2 bromo, 2 chloro, propane. So this is how you name the particular organic molecule. So in this video, we are going only to talk about how to name and a brief introduction of those molecules or functional groups. In the next video, we are going to talk about chemical reactions associated with those chemical functional groups. So the next functional group, which is very useful or very relevant to our daily life, is the alcohol functional group. But this is actually incorrect naming. So many students in the exam, they write it as alcohol functional group. So this is incorrect. It is actually called hydroxyl functional group. So this is the correct naming. So let's have a look of the 3 types of alcohol. So the first type is primary alcohol. So whenever you have something like this, it is a primary alcohol. And this OH part corresponds to the hydroxyl functional group. And whenever some chemical molecules have hydroxyl functional group in it, we call them alcohol. This is just how we name those kind of chemical species. So a primary alcohol is defined as the carbon attached to the OH group or the hydroxyl group is attached to one other carbon atom only. So for this particular carbon atom, we know that it's connected to only one other carbon atoms. So this implies the OH group is at the end or beginning of the carbon chain. The reason for that you will see very shortly when I introduce secondary alcohol. So a secondary alcohol looks like this. So it is when the carbon that is attached to the hydroxyl functional group is connected to two other carbon atoms. So this means it is at the middle of the chain. Because it is only possible for the carbon atom to be connected to two carbon atoms, one on the left, one on the right, when it is in the middle of the chain. If it is at the end of the chain, we know that it will be connected to two hydrogens and only one carbon. So that's why when you have a primary alcohol, you know 100% the hydroxyl functional group is located at the end or beginning of the chain. And the end or beginning is really the same thing, depending on your perspective. So the last possibility is tertiary alcohol. So this is only possible if we have this kind of arrangement. So the carbon is still at the middle, and there is alkyl group connected to the carbon with the OH functional group. So this is tertiary alcohol. And as you can perhaps imagine, the primary alcohol is the easiest for undergoing chemical reactions because the OH group is very exposed. And the tertiary alcohol is the hardest because it is really hidden behind a lot of complicated groups. So it is the least reactive. So how do we name those kind of alcohols? So let's look at this primary alcohol. Because we only have two present, a carbon present, it's called ethanol. So this is what you will consume when you drink alcohol. We do not need to give the position of the alcohol of the hydroxyl group because it is at the end of the chain and there's only one possibility. So I guess a naming convention for the hydroxyl group is that you have ethane and then you drop the E and add OL, so which becomes ethanol. And this OL, I think, have something to do with the name alcohol, because alcohol also ends with OL. For this secondary alcohol, let's have a look. So it is the base is like propane. And we know that when we name alcohol, we drop the E and then add OL. And in this case, we need to assign it with a position because, as you can see, it can go in multiple places. So it is connected to the second carbon atom. So it is called propan 2OL. So that's how you name this particular molecule. For this one, let's have a look. So we also have propan. So we drop the E and replace it with OL. And here it's on the second carbon atom, so propan 2OL. But also don't forget we have this alkyl group going on at the second carbon atom as well. So it is 2, because it only have one carbon, so it's 2-methyl propan 2OL. So that's how you name this molecule. So whenever you have methyl group and the hydroxyl group both on the same carbon, then you know you get a tertiary alcohol. If it's at the middle, you can tell from the positioning number, it's the secondary alcohol. If you get something like propan 1OL, then you know it is the primary alcohol. So it looks like this. And there's no propan 3OL, because if it's propan 3OL, it's the same as propan 1OL. And we always want to take the least number possible, the smallest number possible. So the next group we want to introduce is carbonyl group. So whenever you have a carbon double bonded with an oxygen atom, so it contains CO, it is the carbonyl group. So this is produced via the oxidation of alcohol. So if you go back to the alcohol on the hydroxyl group, which is OH, oxidation is defined as the loss of hydrogen or the gaining of oxygen. So imagine losing this hydrogen and then gaining an extra bond with this oxygen. Also, you need to lose this hydrogen because carbon can only be connected to 4 things or form 4 bonds. And now you have the carbonyl group. So it is really just the oxidation of alcohol. And that's why we talk alcohol on the hydroxyl group and carbonyl group together, because they are kind of related. So the first thing is we want to discuss is the carboxylic acid. So it's the COOH group. So looks something like this. So it is an acid because this hydrogen can go away. So it is acid. And this whole group, that's when it becomes confusing. It's called the carboxyl group, not the carbonyl group, because this is only the CO part. If we have COOH, it's called carboxyl group. So it is formed by oxidation of primary alcohols. So for primary alcohol like this, for ethanol, when you oxidize, it turns into ethanoic acid. So it have gained one oxygen and lost two hydrogens. So gaining of oxygen or losing of hydrogen means it is oxidized. So how do you name this chemical molecule? You first have two carbon atoms with only carbon to carbon single bond. So you start with ethane. And as with everything, you drop the E and change it to something called OIC acid. So you add this two here. So it becomes ethanoic acid. So that's how you name this chemical species. So I think it's the same for naming everything. The first thing you need to do is to drop the E, and then you add whatever suffix that is appropriate for this functional group. So for the acid is OIC acid, for alcohol is OL, so on and so forth. And a very important observation that I hope you can find is that for the chloro, we do not drop the E. So remember we have like chloroethane. So why is this the case? It's because the chloro group in general have low priority. So everything with low priority is attached to the front. And anything with high priority, like ethanoic acid, is attached to the end of this naming. So that's another way you can tell which functional group has high priority and which ones have low priority. So the position of the COOH, the carboxyl group, must be on the end of the chain. And this is to be expected because it's formed by the oxidation of primary alcohols. And we know that primary alcohols have the hydroxyl group at the end of the chain. So when it undergoes oxidation, the thing that changes is the hydroxyl group, which becomes carboxyl group. So it should also be located at the end of the chain. So let's practice. Draw pentanoic acid. So pent means we have 5 carbon molecules, carbon atoms in the molecule. And we know that because it is acid, or the carboxylic acid, it can only be formed at the end of the chain. So COOH, always at the end. And then you just draw the other hydrogens here. So this is an acid. And I think something that is interesting is to discuss the solubility of pentanoic acid. So we know that pentane is not soluble in water because it is non-polar. But pentanoic acid is slightly soluble. Because the COOH group, this is partial negative, partially positive, partially positive. The COOH group have very electronegative oxygen. So the COOH part is polar. And this enables the acid to attach with water, to interact with water via the dipole-dipole interaction. But why it's slightly soluble, but the whole chain, So the whole carbon-hydrogen chain is non-polar. So overall, it is not very soluble. So in general, as the chain length increases, the solubility in water decreases. So for ethanoic acid, it is very soluble. This is basically your vinegar. It is very soluble, as you would know, because the non-polar part is relatively small compared to the polar part. So that makes ethanoic acid soluble. So now let's move on to another functional group. It's called ester, so the COO group. So it looks something like this. So you have R, which represents the rest of the carbon chain, so something like this. And then you have a carbon attached to oxygen, then attached to another oxygen. But it differs from acid because it is the other oxygen is not connected to hydrogen anymore. It's connected to another carbon chain. So this is what ester looks like in general. So the COO, luckily the name is very not confusing. So it is the ester functional group. So this is formed by reaction, we will talk about this in detail in next video, between alcohol and carboxylic acid. So essentially, you have something like this. So this is the acid, this is the alcohol. So the H attached to the hydroxyl group would react with the OH in the carboxyl group to form water, so H2O. And then, after you form water, the two oxygen atoms connected to each other. So you get this COO functional group. And this is called the ester link, or ester linkage. So it is a product of primary alcohol and carboxylic acid. So how do you name ester? I think to make this more concrete, I will delete one carbon atom from this carbon chain. And the reason will become clear once I introduce how to name this molecule. So the name has two parts, or two words. The first part is given by the alcohol. The second part is given by the acid. So when we look at the alcohol, it looks very similar to the alkyl group. So by alkyl group, I mean something like this. Looks very similar to the alkyl group. Because I think you can visualize this as the COO belongs to the acid. and the alcohol only have the CH part. So that's why when you name the alcohol part, you name this exactly the same way as you would name the alkyl group. So here we have 3 atoms in the carbon chain, 3 carbon atoms in the chain. So it starts with prop, and because it's alkyl group, it's propyl. And for the second part, we classify the acid part as the main chain, so the important part, because it contains the ester link. So the main chain, before it is called ethanoic acid. So we drop the OIC acid part because this belongs to the carboxylic acid, and now we no longer have a carboxylic acid. We replace the OIC acid with OATE. So it is called ethanoic. So this is the name of the ester, propyl ethanoate. The propyl part comes from the alcohol. So before the reaction is propanol. So the propan 1O turns into the propyl part. And the ethanoic acid becomes ethanoate. So now let's name this molecule. So how can we tell which one comes from the acid and which one comes from the alcohol? So the acid, remember, is always something connected double bond to this particular oxygen. So this part is the acid, and this part is the alcohol. So because we know it has 2 parts, so the first part, which has 4 carbons, is the alkyl group. So the name is butyl. And the acid part only contains 2 carbons. So we know it is ethanoate. So the name is butyl ethanoate. So always look at the carbon double bonded to this oxygen. And this indicates that the part is acid. And for the carbon single bonded to the oxygen, this tells you it is the alcohol part. The third functional group is aldehyde, or the CHO group. It all have something to do with the carbonyl group, the CO double bond. So it is also formed by the oxidation. So it's formed by partial oxidation of primary alcohol by weak oxidizing agent. So carboxylic acid is complete oxidation, and aldehyde is partial oxidation. It's like the intermediary step between alcohol and carboxylic acid. So the name is something Al. So let's look at one example. So it is the COH group, and acid is the COOH group. Because of this addition of oxygen in the acid, we know that the aldehyde is not as fully oxidized as the carboxylic acid. Because remember, oxidation is defined as addition of oxygen. So this is called ETH. So you drop the E and replace it with Al, ethanol. So this is how you name aldehyde. So the last functional group to do with the CO double bond is ketone. So it is the CO bond itself. So it looks something like this. there's no hydrogen attached to the second carbon because it already has 4 bonds. So it is also formed by oxidation. But look at the position of this ketone. It is at the middle of the chain. So what reminds you when you see this? It should remind you of secondary alcohol. Because secondary alcohol have the hydroxyl group also at the middle of the chain. So if you have something like this, you remove 2 hydrogens, which is the definition of oxidation. Oxidation is the removal of hydrogen or gaining of oxygen, and then form a double bond between carbon and oxygen. So it becomes like this. So how do you name this molecule? So the basis is propane. As with every naming, you drop the E. And the ketone is represented by 1, so ONE. And the position is also important. So you need to name this to indicate the position number. But as you know, in this case, because there's only one possibility, you can still draw the molecule without knowing the position number. So just name this as propan 1. If you have something more complicated like this, you need to assign the position number. So this have 5 carbon atoms. So drop the E. And assign the position number 3. Because if you don't give the position number, maybe it's possible for the ketone to end up in the second carbon. And the name of this functional group, as we have discussed early in this video, is called the carbonyl group. So really, if you think about it, the ketone aldehyde and ester and carboxylic acid, they are all derived from alcohol. It's all obtained from the oxidation of alcohol, as well as the reaction with alcohol in the case of ester. So that's why alcohol is really a very important chemical species. So the last 2 functional group you need to know for the purpose of VCE exam is amine and amide. So amine is the NH2 group. So it is the addition of amino functional group. So this is called the amino functional group. You may be very familiar with amino. So sometimes you know the term amino acid. And it indeed have something to do with the amine functional group. So for VCE exam, you only need to know the primary amines. So the general formula is something to do with the rest of the carbon chain attached to N2. So one example is this. So essentially you replace one of the hydrogen by nitrogen, which is further attached to two other hydrogen atoms, because we know that nitrogen has 3 valence electrons. So it wants to form 3 covalent bonds. And the definition for primary amines, amines, is different from the definition of primary alcohol. So whenever you have 2 hydrogens attached to the nitrogen atom, it is called primary amines. So even if you have something like this, which is at the middle of the chain, this is still primary amines, because the nitrogen atom is connected to 2 hydrogen atoms. So let's practice naming amines. So here you have 4 carbons in your carbon chain. So it is something to do with butane. You have a double bond. And here, obviously we have name from left to right or from right to left. But as you would notice, that if you name from left to right, the position of the double bond is on the second carbon. If you name from right to left, it is also on carbon number 2. So the goal is to minimize the total number in your naming. So if you name from left to right, the amine group or the amino group is on carbon number 4. But if you name from right to left, it's on carbon number 1. So it is more efficient to name from right to left. So that's why we choose this direction. So but2 ENE. So this is how we name butane with double bond. But here, because we also have the amino functional group, we need to drop the E. And what we do is we assign the position of the functional group. So it's on carbon number 1. And then we state which functional group it is. So it is the amine functional group, or the amino functional group. Also, we have this trans arrangement. So the name is trans but2 EN1 amine. And as you can see, amine takes priority because it is named towards the end, and the double bond does not take priority in this case. But if you have something like this, then the carboxylic acid would take priority. So the actual table I will show you later. But how do you name this molecule if you know that the carboxylic acid will take priority? So instead of calling it amine, now when it does not take priority or starts at the beginning of the naming, you change the name to amino. So the suffix for this functional group is amine. The prefix of this functional group is called amino. So it's called amino ethanoic acid. You don't need to give the name because we know that ethanoic acid can only be at the end. Since we only have 2 carbons, there's only really one possibility. So this is an example of amino acid. And it is the building block of proteins. So the last functional group for today is amide. So amide contains the functional group CONH2. So it looks like this. And you know that it should always be on the end of the chain. Because here carbon is already connected with 3 bonds. So it's only have 1 bond remaining to connect with other species. So it can never be at the middle of the chain. So it is formed by the reaction between carboxylic acid and ammonia. Again, it is a condensation reaction. So water is produced. And you have this direct link with nitrogen. So the CONH2 becomes the amide functional group. So we also need to know primary amide only, which is nitrogen connected to 2 hydrogens. So the naming of amide is also very similar to other species. So if you have something like this, so the basis is methane. Again, you drop the E. So you drop the E and add amide. So it's methane amide. You have 4 carbon in your main carbon chain. This is called butane because you drop the E and then add amide. So this is how you name amide. So for methane amide, how do you draw the skeletal formula? So it's actually just something like this. So this is the skeletal formula. And there's like an invisible carbon here. But you don't need to show the carbon. Because by default, carbon is at the end of each chain. So now let's look at how to name organic molecules with 2 functional groups. So which one takes priority? So we go from the highest priority to the lowest. So the highest priority is the COOH group, or the carboxyl group. So it only have a suffix. So it only ever goes towards the end. So it's called OIC acid. Next up is the hydroxyl group. So the suffix is the OL. And it can also have a prefix when something else takes priority. In this case, the only possible is carboxylic acid. So it's called hydroxy. For example, when we have this molecule, we always name from the carbon that is connected with something that has high priority. So the acid, the carbon connected to the acid functional group, or the carboxyl functional group, takes the number 1. So this is number 2, number 3, number 4. So the alcohol is at number 2. So the name should be 2-hydroxy, and then you just name as normal, butanoic acid. So instead of having OL as the suffix, because acid takes higher priority, the hydroxyl functional group changes the name to hydroxy. The next is the amino functional group. So the suffix is amine, and the prefix, as we have already discussed earlier, is amino. Amino something. Then is the alkene. So we know the suffix is ene. Then is the alkyne, so the triple bond. So it's YNE. When something else takes priority, as in the let's find an example. As in this case, so it is something en something else, and this one is something yn something else. The lowest priority is the halogens. So it does not even have a suffix. So it will never go towards the end of the naming. It will always present at the front. So you have chloro, bromo, things like that. Okay, so the last practice I want to do today is an actual exam question. This is the 2018 chemistry exam. The first question is worth 6 marks. And it's really just testing on your definition and the ability for you to name chemical compounds. So first is to draw the structural formula. So structural formula is the full diagram of your compound. So you need to know the definition really well. 2-methyl-propan-2-ol. So let's start with the carbon chain. So from prop, we know it has 3 carbons in the main carbon chain. And we have methyl group on carbon number 2. And we also have the hydroxyl group on carbon number 2. So this is a tertiary alcohol. Next question, give a molecular formula of but2-YNE. So you can use the general formula, which is CnH2n minus 2. So here you have but, so it's 4 times 2 minus 2. So it's C4H6. Or I recommend you just to draw out the diagram. So at the second carbon, you have 3 bonds, so 1 hydrogen. So you indeed have 6 hydrogens present. So the last one is to give the naming of this compound. So first, we want to make the identify the longest carbon chain, and then to make a decision of whether you go from top to bottom or to bottom to top. So here, because we want to minimize the total amount of number in our system, when we go from bottom to top, so you have the methyl group on the 3rd carbon, the bromo on the 4th, and the 5th. But if you go from top to bottom, it becomes 2, 3, 4. So for going from top to bottom is the more efficient choice. So this is carbon number 1, 2, 3, 4, 5, 6. So we know we have 2 bromine atoms, and it is on position number 2 and 3. So it's 2, 3 dibromo, 4 methyl, and for 6 carbon we know it's hex. And since we do not have any double or triple bond, it's just A and E. So here you go. This is 3 marks in the exam.